Hey, we talked about wood floating, and you guys know why wood floats, because the buoyant force acting up equals the weight acting down. Isn't that true? In fact, isn't it true that anything submerged in a fluid will be buoyed up by a force equal to the weight of the fluid? Now, we said fluid and not liquid. Why? How about someone says, I can see why a fish doesn't sink, and I can see why a hunk of wood doesn't sink, but I don't see why that air-filled balloon doesn't sink. Wait a minute, wait a minute. If you see one, you've got to see the other. Because the air-filled balloon is displacing air, yeah? And isn't there a buoyant force on the air-filled balloon? And if that buoyant force is more than the weight of the balloon, what will the balloon do? It'll go up. If that buoyant force is equal to the weight of the balloon, what will that balloon do? Stay there. And if that buoyant force is less than the weight of the balloon, it will sink. So if I take a balloon, I blow it up with air, and I let it go, whoop, it sinks. Why does it sink? The balloons you see at the end of the string at the circus, honey, those are filled with helium. Okay? But why is it you blow your own up with air and it sinks? How about that air, gang? Is that air more dense or less dense than the air outside? It's a little bit more dense. Do you know why? Because the stretched rubber is tending to compress it. So it's slightly compressed. So it's more dense than outside. That means its volume of air will weigh more than the equal volume outside. It's going to sink. But you use helium. The helium is very, very light, not as heavy, huh? Each molecule is not as heavy, so it is not as dense. So the helium-filled balloon is simply lighter than the buoyant force, and up it goes.